Alright, I'd like to investigate spatial analysis in a QGIS project. Before we start in this particular one, to go to the project properties and the CRS transformation, and it's very important in what we're working with here that the coordinate reference system is all similar, or at least that we understand what we're working with. So I'm going to do this project in the UTM Zone 18, and if you'll notice down here, the units are in meters. So setting that for the project. I'm going to bring in now an area, the roads, and this is under the Cougar data out of Steuben County, and bring in these roads. So there are the roads in Steuben County, and then we need some imagery for this activity. So I'm going to the town of Corning, and all the way down here I'm going to bring in the shapefile. So this gives us imagery areas, and I'll set the transmission of that to about 50% so we can see through it. Okay, so you can see those are the images for the city area. And I'm going to bring in just an image or two. What we're focusing on is an area around Corning Community College. So Corning Community College is a little bit south of Corning, and it occupies the space here. So I'd like to bring in these particular images so I would identify what they are. And this is 687, 772, so I want to find that if I can. 687, 772. Okay, so I've brought that in, and unfortunately it doesn't show up here. So one of the problems that we may have is that we've got some coordinate reference system issues. So I'd like to look at what the coordinate reference systems are from this imaging, and you can see what it is. It's a generated scenario. And down here in the generated CRS, you notice that it's in feet. So that's kind of an issue. So we'll look up here at this one that didn't show up, and we'll see that it came in at New York Central. So it's in units of meters, and so what we have is a mismatch here. So I'm going to select the generated variable, and you can see that now I've got the image. So whatever images I bring in, I'm going to need to convert them into this particular area. So now I'm going to go and bring in these 6 images and convert them. Uh, 770, 768. So 770, 768. And then 684, 772, and then the 3 below. So now I'll need to reset these coordinate systems down to what we are using. Okay, so now I have the area around the college. And my next thing I'd like to bring in is the regional digital elevation maps. So regional digital elevation maps, they're under the Cougar Southern Tier. Okay, and then look at the full extent of what we have. So you pull the roads up on top. So we've got regional data here. The digital elevation maps. I have the roads and this area. So I've got a lot of material that's outside really the area of interest. So it could start to slow us down a little bit. And I may bring this regional data here down underneath the images. So there's my images now. Okay, so the first thing that I want to do is to limit this amount of this elevation data so that we process only information in a reasonable area around the college. So to do that, I first need to make sure under the plugins that the GDAL tools are highlighted, and if you don't have those, you may need to go get them with the Get More button here. But this is GDAL tools in GIS, and they're raster tools. We need to make sure that's on. And under raster, we now have some tools that we can work with. So the first thing I want to do is to extract, and I'm going to extract with a clipper. And I need to select this regional data, and I need to tell it where I want to put things. So where we will be putting things for this exercise is to put them in your answers assignment 14 folder, and we'll just call this Corning Community College Digital Elevation Map. And we can select here the extent by dragging a value on the canvas. So if I make a one-point selection and drag over the top, I have a value for making this clipping. So at this point now, so we have a digital elevation map. Now it does appear to be a little bit less quality than what we had before. So there may be some artifacts. Now I'm going to turn off the larger area, and actually I can turn off the index as well. So we have an area here that is around the college. So we have a smaller area by which to do some analysis, and that's the intent that we have. Now one thing that's important is that we need to look at what this DEM data is about. And so when I look at this coordinate reference system, and I'm going to look at the metadata of the original data sets, I'm going to scroll down to see how this has been recorded. And down here at the bottom you'll notice that this has been recorded in units of meters. Now why this is important is that we need to make sure that we're using factors that make sense. The factor that I'm talking about is a thing called a z-factor. And the z-factor relationships mean that if our x, y, those are our projections for latitude and longitude, and z, if they're all in meters or they're all in feet, we can use a z-factor of 1. But if we're using a projection like an Earth-centered projection where X and Y are in degrees and Z is in feet, then we need a Z factor of 370,000. And if it's in meters, but those are in degrees. So this is a very important aspect when you do spatial analysis, is that the dimensioning that you're using makes sense. So when you come back, we'll start to do some processing on this area.